In today's video, we're going to take a look at this one new firewall appliance, and this one has some very impressive specs. It's got an Alder Lake CPU, DDR5 memory, 3 2.5 gig network interfaces, and in the case of this model, 2 25 gig network interfaces. So yeah, this thing is really impressive. So let's take a look at it. So this is the Gowin GW-BS-1UR1, and it's a brand new device that they're releasing to the market. At the time of making this video, it's not currently available to purchase, but as soon as it goes available, I'll put links in the description and in a pinned comment. But for now, what they've done is they sent me a review sample so we can take a look at this brand new product. So yeah, to be completely transparent, Gowin have sent me this free of charge to review, but they won't be seeing this video before it goes live. They've not told me anything to say, so I'll be providing my honest feedback on it. But this is a really interesting device. If the name Gowin sounds familiar, or maybe you recognise this logo from somewhere and you can't quite put your finger on it, about a year ago, they released the R86S line of mini PC firewall appliances. And this was quite well received, and it seems to have been quite a fairly popular product. And it was a small desktop mini PC form factor firewall appliance, really. It was pretty powerful, it was available with 10 gig networking. It was a really good device. And when I saw it, it looked neat, but for me, all of my networking equipment is rack mounted. So I didn't really have an interest in the desktop form factor, so I didn't really pay that much attention. But what they've done now with this product is they've taken that, updated it with improved specs, and put it in a rack mount form factor. And that's now much more appealing to me, so here we have it. So first of all, let's talk specs. This has an Alder Lake i3 N305 CPU. Now if that model number with an N in it sounds a bit weird, this is a new series of chips that Intel's launched with the N designation, and what these are low power, highly efficient chips. So the i3 N305 has 8 cores, but unlike the desktop and regular laptop i3s, which have some performance cores and some efficiency cores, the N series CPUs only have efficiency cores. So this has 8 efficiency cores. So it's not going to be as powerful as, say, a full-size desktop chip or a full-size laptop chip, but it means it's very power efficient, and it's ideal for a device like this. So yep, we've got an 8-core i3 N305 CPU, which is a brand new Alder Lake chip. We have 32 gigs of DDR5 RAM, which is absolutely ridiculous. Don't know if I'll ever use that much, but it's nice to have as much RAM as that. So you've got 32 gigs of DDR5 RAM, 32 gigs of eMMC storage, and as I mentioned in terms of network interfaces, you have 3 2.5 gig NICs. These are Intel i226 based NICs. On my model here, we have 2 25 gig NICs based on the Mellanox ConnectX-4. This product's going to be available in 2 different versions. So this is the higher end version with the 25 gig NICs, or you can get a cheaper version which has 2 10 gig NICs based on a ConnectX-3. So those are your 2 options for network interfaces. And as you can see on the back with these 2 tiny little aerials, it also does have built-in Wi-Fi. It's a bit of a weird thing to have, but when we see inside, it's based off of that R86S device, which is more of a desktop device where Wi-Fi is maybe a bit more sensible. So they've kept the Wi-Fi in this. So this is Intel AX201 Wi-Fi, which is 2x2 Wi-Fi 6. I think it also includes Bluetooth potentially, but the thing to bear in mind with this Wi-Fi is it doesn't support any sort of access point mode. It can only work as a wireless client. Now, this isn't really an issue. I would never recommend using a sort of PCIe or desktop-based Wi-Fi card as an access point. I'd always recommend just to get an access point. But it could be useful as a client. It's not something I really see myself using too much or being super excited by, but it could be useful in certain situations. For example, as part of my home network currently, I have a tiny little MikroTik access point, and it's set up to connect in station mode to my phone's hotspot. And that's then wired into my router as a secondary WAN connection. So if my primary internet connection goes down, what I can do is turn my phone's hotspot on, the MikroTik will connect to that, and my router will enable that as a second WAN connection, so all my devices will connect through my phone's hotspot. So it gives me a backup mobile data WAN connection without needing a separate data plan. So I suppose one thing you could use this for that kind of thing. Now obviously this is a rack mount case, so these little aerials probably aren't ideal because this would be inside a rack which would just block the signal. But if you wanted to do something like that, you could probably get some sort of external aerials, wire them around into this, have the aerials outside the rack, and it could probably work. So yep, you've got built-in Wi-Fi if you want it. So now let's talk pricing. Bear in mind these prices are from their pre-release datasheet, so these could change when they go on sale and different countries will all be different. But for the 10 gigabit version, they're quoting $535, and for the 25 gig version I have here, they're quoting $585. Now, when I put these videos out about these devices, people often freak out about the price, saying how ridiculous that is. Yes, it is not the cheapest thing in the world, and yes, you could probably buy a bunch of desktop PC parts and build a desktop tower form factor device with a bit more CPU power for significantly cheaper. However, the thing to bear in mind is rack mount devices are a much more niche, much lower quantity device, so they will always be a bit more expensive. And to be honest, that sort of price for this level of power in a low power use, relatively efficient 1U rack mount device isn't too bad. For context, my sort of go-to firewall for a basic gigabit or slightly above gigabit firewall is a 1U Supermicro device with an Atom C3000 chip. To buy that new, you're looking about £800 to £1,000 easily. So yeah, it is expensive compared to like building your own little desktop or buying a cheap little NUC, but it isn't a bad price for this level of spec. But of course, those prices could change. So yeah, let's look at the specs. Now let's do the more exciting thing and take a look at the hardware. Now in this video, I'm not going to go into too much in terms of performance testing. That's because when I knew I was getting sent this, I thought, great, I'll get the one with 10 gigabit network interfaces, so I'll test the performance of that. So I went out and bought another 10 gig NIC to test it with, and then got the one with the 25 gig NICs, which is great. I've got a much more higher performance device, but I don't have another 25 gig NIC to test this to its full potential. So I've done some performance tests with another 10 gig NIC, so we'll talk about those performance results. But what I think I might do, if there's enough demand for it, so if you want this, let me know in the comments, I might go and get another 25 gig NIC and do some much more in-depth performance tests in a separate video. So this video will show some performance tests, but what we'll mainly focus on is taking a look at the hardware, firing up, taking a look at it working, and talking about it. So yeah, here we have the device. It's a pretty nicely built thing, so it's a sort of black rack mount form factor case. It feels pretty solid, it's a very durable case, it feels really nicely made. And as you can see, as I talked about before, on the front you've got the 3 2.5 gig NICs, 2 25 gig NICs, or 10 gig if you went for that version. And then you've also got 3 USB type A ports. You've got a pair of LEDs here for power and disk activity, and an RS-232 COM port, so it's an RJ45 serial port, which is nice to have as well. Taking a look around the back, we can see we have 2 antennas here. These are actually removable, thankfully, because obviously these may be an issue. If you were trying to put this into a rack, these sticking up might kind of get in the way. You could possibly try and fold them down, but realistic with this, even though it does come with these smaller antennas, I imagine you would probably, if you wanted to use the Wi-Fi, need an external antenna and wire it over a cable into these ports, so you can have the antenna outside of the rack. So yeah, we can take these off, but they are just standard SMA connections, so you can fit external antennas if you want. We then have a VGA port, a pair of 40mm fans, a power on-off switch, a power supply inlet, just a standard IEC power inlet, and a fan for the power supply. So it's all fairly simple. So now the exciting thing is to take a look inside. And what's nice to see is they've actually used thumb screws. So every other device I've seen like this has just been a standard screw on top, so there's been a few screws all the way around you've got to take out. But on this, they've actually put on these thumb screws. So it's actually really nice. It's much easier to take this thing apart because of these thumb screws. So yeah, it's nice. Especially because obviously they're captive, so you then don't lose them, which is ideal. So yeah, we can take that off, take that up, and remove the top and see inside. And now here we are inside the device. We'll take a quick look at a sort of summary of all of this, and then I'll actually do a full teardown, take it apart to see how it's built, because it's quite interesting. Because you'll notice this doesn't look like a conventional device with just one big motherboard, maybe an expansion card. There's a lot more cables and stuff inside here. So let's talk about that. So as I mentioned, Gowin make the R86S series of desktop mini PC type firewall appliances. So what they seem to have done here is essentially taken that and mounted it into a rack mount case, which is why you've got this weird sort of setup here with these 2 boards here with a ribbon cable and a lot of built-in cables. And while at first that does seem a bit weird, it makes complete sense, because designing and manufacturing PCBs is very expensive. The rack mount version is probably a relatively low volume product compared to their regular desktop versions. So being able to use the desktop version boards inside this case makes this a lot cheaper to produce. And what's interesting with this is this seems to potentially be their as of yet unreleased R86S-N model. So this is the model they've been touting for quite a while with the Alder Lake i3 CPUs and stuff like that, but it isn't available yet, and there hasn't been really any performance test reviews of that model either. But what this seems to actually be is that model, but in a rack mount case. So I'm kind of reviewing both models at this point. So yeah, that's what you've got here. So what you have essentially is the R86S PC, which is normally the sort of regular board with the copper ports, and a separate board with your network, with your 10 gig and 25 gig ports. And they've taken these, split them out side by side, and they have a ribbon cable linking them. Then to bring the ports to the outside, what they've got is this little board here, which has the USB ports and COM port, and these are connected with these cables into the ports on the actual main board, because obviously normally this would be inside a metal case and these ports would be exposed to the outside, but because they're mounting it in this rack mount form factor, they need to bring these extension cables round, which makes sense. So now in terms of video output, you might notice something quite interesting, because you've got VGA, but that then converts to HDMI, and then the HDMI runs into the main board. So why have they done that? Well, interestingly, this device seems to have been designed based on a lot of community feedback. There's a subreddit designed for these R86S desktop mini PC type routers. And what they did when they were designing this is they created a thread in there basically saying, right, here's our plan, we're making a rack mount version of it. Here's some sketches, here's some ideas, here's the specs, what do you think? And they curated a lot of feedback from that Reddit thread and responded to a lot of it, and quite a lot of the feedback that they received, they've actually built into this device. So their initial concepts of this device had an HDMI port on the front. However, quite a lot of people commented and pointed out that in many situations such as data centers, most people still use VGA monitors. So if you're in a data center, it'll have a crash cart, which is basically a trolley with a monitor on it and a keyboard and mouse, and you wheel it around the data center to the rack and plug it into your equipment. Those almost always are VGA. Half the time it's the oldest, most broken old monitor with a random VGA cable hanging off it. It might have DVI if you're lucky, it definitely won't have HDMI. And then if people have KVM switches in the racks, pull out KVM consoles, those are almost always VGA. And that's why even now, if you buy a brand new top-of-the-line Dell server, it still has VGA on it. So people put that feedback in, and they went, yep, that makes sense. So what they've done here is instead of having HDMI, it has VGA. But obviously the main board only supports HDMI because it's a modern Alder Lake chip. So what they've done is they basically put this little board in here, which converts HDMI to VGA. So it's got an active HDMI to VGA converter chip on it, and that's how they're doing it. So it's quite neat. Now, of course, this does mean if you wanted HDMI out of this, you've not got that, which may be a disadvantage for some people, but you could easily get around this, because obviously this is an HDMI cable here. What you could do is you get something like this, which is like a panel mount HDMI extension, so it's a pretty neat little device. These are very inexpensive, and all you need to do is take this board out here, figure out some way of mounting this in the back of the case. You could probably just use some washers with those screws, mount that in there instead of the VGA connection, and then plug that into the HDMI cable. So if you did need HDMI out, you could do it. It has HDMI internally. It'd be relatively easy to mod to give it HDMI, but yep, it has VGA, and that was based on community feedback, which is quite cool. It's nice to see a company like this actually taking community feedback on board, rather than just pumping out products and hoping people like them. I also fully expect them to be watching this video, so throughout this video you may hear me actually give bits of feedback that would only really be relevant to Gowin, but I will actually point out a few little things that they can maybe change or tweak. So yeah, that's how they're doing video output, which is HDMI internally, but then it's converted to VGA by this active little board. The other thing you might notice over here is we have this 512 gig NVMe drive. This isn't something that comes as standard. On their datasheet, they listed it as being available with a bunch of different NVMe drives, or none if you don't want them. The main board has eMMC storage, as 32 gigs of that, but this is an optional extra. I don't know why they included it here. On their sort of Reddit thread, they put a little comment saying, as a gift to people who have pre-ordered this, because they did have a pre-order system set up for this, we are giving everyone a 512 gig drive. So I suspect, because even though this is a review sample, it's essentially a pre-order unit. So they've included that there. It's just a basic NetAC N930 Pro M2 NVMe drive. It's 512 gig, but I think it's DRAM-less. I won't really use it in this, so I'll probably end up taking it out and using it for something else. But yeah, if you see the NVMe drive in here, that is an optional extra, so that might not come with yours depending on what spec you buy. But yeah, it does mean you've got an NVMe M.2 slot here, so you could use that if you wanted to, which is quite nice. I'm not really going to use it, but there is certain situations you might have a firewall that's going to be collecting a lot of log data or something, and it could be useful for that. So the final thing we'll talk about before we take it apart is the power supply, because this kind of caught me off guard. It wasn't really what I was expecting them to do. So what they've got here is a Flex ATX power supply. So this is a standardized PC power supply. It's designed for small form factor systems, and that's installed here. But of course, the R86S board and everything is purely 12 volts. So what they're actually doing is none of these cables are actually being used. All they're doing is using the 12 volt EPS connector into this little subboard here and providing 12 volts to this, which then passes it on to the R86S main board and powers everything up. So all these cables aren't really being used. And the only thing they have is on the 24-pin ATX connector, they've got this little link in here that just links the power on signal to ground, so that turns the power supply on. And as you can see on the back there, it's just taped on to keep it secure. So it's an interesting way of doing it. And what kind of initially confused me here is I was looking at this going, why have they linked the power supply on here, but then they have an on-off switch on the back? because surely that should connect to that to turn the power supply on and off. Well, interestingly, despite this being a latching power switch, this is actually a soft power switch. This actually triggers a clean shutdown if you turn it off. So you turn it on, machine turns on, turn it off, it'll actually initiate a clean shutdown and turn the machine off. So it does mean when the power supply is off here, when the switch is off here, your power supply is still turned on and using a little bit of power. I think this one draws about 6 watts when you're drawing nothing from it. So that's a little bit interesting. I suppose it's nice in the sense it means that you can turn that off and do a clean shutdown. But the downside I found is that there's no way to force a shutdown. There's no equivalence with this of like holding the power button down to hard power something off. So if your machine locks up, for example, you can't turn it off or reset it with a button on the device. You have to pull the mains out and put it back in again. So I think given that, I'd have rather this just turned the power supply on and off and would just do a hard power off, and then I can just separately clean shut down the OS from within it, or do what a lot of devices like this do and have a switch on the back that isolates the power supply and turns the power supply off, and separately have a little push button on the front to do a clean shutdown. So the power supply is an interesting decision, and this is kind of an interesting way of doing it, but I mean, it works. So the one thing I would really say about this isn't the most power efficient way of doing things. And we'll take a look at some tests I've done later. Here they've got a 250 watt power supply, and they're not going to be drawing anywhere close to that. And for people who don't know about power supplies, a power supply is generally at its most efficient round about its sort of middle of its power rating. So with this sort of device, round about 120 watts would be the most efficient that this power supply would operate at. If you're operating a power supply way below its rated capacity like you're doing here, it's not going to be running at its most efficient. So you're generally better off running from a lower power supply. You're generally better not completely over-speccing the power supply and get something much more close to what you're drawing from it. So they're not really doing that here. And with a Flex ATX power supply, the lowest you're going to get is 150 watts, whereas this isn't going to draw anywhere near that. What most other devices I've looked at in this form factor tend to do is use an open frame power supply. So you have something like this, where the power supply is this type of module here, which only outputs 12 volts. So you put mains in the back, get 12 volts out, and that's the only voltage this thing produces. And this is likely to be a lot more efficient. These are also available in much lower wattages. The one here is 150 watt, but the other similar device I looked at previously only had a 50 watt power supply, and that would be a lot more efficient. Now, I can see why they've done it this way, because this is a much easier to replace module. It's a single part you can replace. They can easily buy these off the shelf and just drop them in. It's much easier to install. And the benefit is that they don't need to do any mains wiring, because on a device like this, you have to have a mains power inlet at the back, wire that across to the power supply. Whereas with this, they don't have to do that because the mains inlet is built into the power supply. They just drop this in. This is also a bit safer because it means that there's no exposed mains inside this. Whereas in a device like this with an open frame power supply, you've got exposed mains terminals down here, and you've got some exposed live terminals on the back of this DC jack or this AC jack. And I'll be the first to admit that I have actually electrocuted myself, well, not electrocuted myself, but given myself a pretty nasty shock off of one of these devices. Now, it was me being really dumb, but I had the device sitting on a table like this. I went to plug a power cable in, went to put the power cable in the back, it was sliding across the table, so I went, right, I just need to grip onto it, and did that, gripped right on there, and plugged the power cable in, and got a bit of a zap. So by doing this with a Flex ATX power supply, they've got completely rid of that, so that's nice, but it's maybe just not the most efficient way of doing it. So we'll take a look at the efficiency later, but that's just something to bear in mind. But yeah, that's their power supply there. So with that out of the way, I think the next thing to do is start digging into this and take it apart and see how they've built it. So now let's start taking this thing apart, and as we're doing it, we'll talk about little observations I've made. So the first thing we'll do is we'll take out the main board here, or the main single board computer, I suppose you could say, because it's all really on this board. So that's this board here, and it's connected to a bunch of other devices inside here. So the first thing we'll do is we'll take off the Wi-Fi cables. I've already taken these off in a previous take of this clip, but I didn't bother putting them back on for this because they're so fragile, so I'll leave these off. But these clip on the Wi-Fi card here, the same connectors you'd use in a laptop, but they're just quite fragile, so you just need to be careful to get them off without damaging them. Then to connect the main board into this board here that has the PCI Express devices, there's this ribbon cable here, so we'll very carefully remove that just because I don't want to risk damaging that, so I'll just flip that clip up, pull that out, and I'll leave that out there. Next up, we have all the devices plugged into ports down the side here. So you've also got the HDMI we've talked about before. That comes up with this HDMI to VGA converter here for the VGA port. You have these two USB ports. These come round here into this board here that provides the front two USB ports. And then you've got this port here that's quite interesting because it's mini USB, which I was looking at going, what is that for? But when I mentioned earlier, this is based off of the upcoming R86SN mini PC. They've released a picture of that, and that has a serial port here. It's a port labeled COM. So what I think they're actually doing here is they're using the mini USB connector, but they're actually transferring RS-232 signaling over it. So essentially it's a serial port. So that's coming over here into this board, which then converts it to the RJ45 port. It's a bit of a weird way of doing it, but I have seen this before. It was a switch from, it was branded Juniper, but I think it was made by a company called Blade, and it was the same. It had a serial port on the front, so a port labeled console, but it used a mini USB connector, which is kind of interesting because I thought that was going to be some sort of USB console and then had to make up a cable, and it was great fun. But yeah, that's what they're doing there. So that's a console port, not USB. 2 USB connections and then HDMI. Now, if I had to give one bit of feedback to Gowin with this, I would just say to maybe do something to improve the sort of durability to vibration in transit. Now, this is a very early version. This is potentially a pre-production version. It's a review sample, so they may have already improved this. But when I received mine, these two USB cables had pulled out, so they were kind of sitting like that. Now, for me, that was fine because I opened it before I even turned it on and noticed that and went, oh yeah, and pushed them back in. But I think with this, they really would be best to have some sort of way of securing these cables. So either have some sort of clip here that holds them in place, or to be honest, even just a bit of hot glue on top of these would hold them in place and could easily be broken off if you needed to unplug it. So yeah, just a sort of little thing for them to work on there. And the other thing as well is just the screws. I found a few of the screws on these boards here had loosened off and they were a little bit rattly. Again, that was probably through vibration in transit, but taking these screws out, I noticed that there's no thread locker or anything on them. So a bit of advice for them would be to put some sort of thread locker on each of these screws just to stop them loosening off in transit and obviously secure these connectors in place. But yep, that's all those cables unplugged. There's now another little cable, little tiny connector here, so we'll need to unplug that. And there's another one on the underside of the board, so we'll need to take that off as well. These will be, I don't know what each of these does individually, but these will be doing everything from carrying power to this board to also carrying things like the on-off signaling from here. Maybe something to do with fans, I don't know. Probably not, but it will definitely be carrying things like the on-off signaling and stuff and the power to this board. It's through this connector here and another one on the bottom. So with that out of the way, what we now need to do is take out the 4 screws holding this board in place, and then we can lift it out. And we'll just need to be very careful because there's that one more connector underneath we'll need to not forget about. So let's take these screws out and see what's underneath this board. So that's all the screws out there, so we can now carefully remove this. And there's that one connector on the bottom there we'll need to pull out. Bear in mind that goes in sideways, so be very careful with that. You don't want to break that off if you're not careful. So that'll pull out like that. That's now disconnected, so we can now, get this out of the way. We'll take a closer look at it. So that's the board out there. So I've also taken the cable off for the big ribbon cable off just to protect it. But that's the underside there. So down here we can see we have 3 Intel NICs. So these are the Intel i226V network interfaces. Up here we have this chip here, which is a GL3523, which is a USB hub. Don't know what we're using that for, presumably some sort of USB, obviously. And then here we have one of those ITE controllers. This is a ITE 5570E. This handles, I can't remember, is that a Super I/O chip, or is it just like a overall sort of microcontroller that handles basic board functions? That's all that is there. What's more interesting is on the other side. So what we'll do is we'll take the heatsink off and take a look underneath. So let's do that now. So the heatsink is just held in with a couple of screws on the back, so these should be relatively easy to take out. So if I undo that there, undo that here. May as well just do this on camera for the first time. Then this cable here does the fan, so we'll unplug that. This cable here is, I think, some sort of CMOS battery, so again, we'll take that off as well because that's stuck to the heatsink. So we'll take that off. And now, let's lift the heatsink off. So let's just carefully ease that off. There we go. Thermal paste. And there we are underneath. So I'll go away, clean this up, and we'll take a look at it. Okay, so I've now gone away, cleaned this all up, and I've searched up some part numbers of these chips, just in case people find this sort of stuff interesting. So obviously in the middle we have the main CPU, so that's the i3 N305. Then down here we have these 2 RAM chips. These are Micron D8CWL chips, which are 128 gigabit or 16 gigabytes each. So you've got 2 there for the full 32 gigs. And these are LPDDR5X. So yep, this does have DDR5 RAM. Next over here we have this chip here, which is an SCY E128CSAG2AB-E00. It's a long model number. But essentially all that is 128 gigabytes of eMMC flash. So that's just our flash storage there. That's the sort of main chips out of the way. A couple of other minor things of interest if you're interested in this sort of stuff. We've got this chip here, which is a slim port ANX447, which is a USB-C port controller. USB-C ports need an additional controller to handle things like plugging in different directions, power delivery, that kind of stuff. And then finally over here we have this chip here, which is a SIPX SP3232EEA. And this is an RS-232 driver. So the idea here is obviously RS-232 works at higher voltage levels than sort of a 5-volt logic circuit like this mostly will be. So what this chip here is, it allows it to drive those higher voltage levels from the CPU. So this allows you to produce the full proper RS-232 voltage levels from the CPU. So that's what that is there. So that's an RS-232 driver. That's really all there is to note on here. You've got the Wi-Fi chipset there with 2 antenna connections. Around the front you can see we have the same ports that you'd see normally poking through the front of the machine. However, what you might also interestingly notice here is there's a USB-C port which is blocked off. And that's because this is obviously that R86N mini PC. So on that version, that'll be your power supply inlet. On the older R86 machines, that's a 12-volt barrel jack. So they've obviously replaced that with USB-C. But obviously on this machine, because it's got the built-in power supply, that gets blocked off. And as final proof, this is definitely the R86N, just in a different case. You can see on the bottom there, it literally has R86N printed on it. And there's a spec as well. So you can see it's an R305, or an N305, 32 gig, 128 gig. So yeah. So yeah, that's the main board. Yeah, it's pretty interesting to take a look at. Other than that, you've got the heatsink as well. That's not really very exciting. It's just got sort of machine metal on the bottom. I think it's just aluminium. That goes on the CPU there. And you've got the battery and that cable which connects to the fan there, of course. You've got the fan on it there. So yeah, that's the main board. So now let's get into this further. So next up, let's take out this board here, which has the network interface on it and the M.2 drive. So take out these screws here and get this out. So that's those screws removed, so we can lift this out. Now, again, just be careful. There is another little cable plugged into the bottom of this, so we'll need to take that out carefully. So that'll just pull out like that. Now that's that board removed. So let's get this out of the way. I'll disassemble this and then we'll talk about it. So yep, that's all disconnected there. But as you can see, what you actually have is this board here, where on the top you've got your M.2 SSD, or your slot if you've not got the SSD in there. And on the bottom, you've got your network card, which you can see is actually a separate board. And we'll talk about this in a minute. What I'll do now is I'll just quickly take this apart a little bit more and we'll take a look at it. Okay, so now let's take this apart a bit further. So I've taken the SSD out the other side. It's just an M.2 drive. It's not exciting. And I've now also taken out the 4 screws holding this network card in. So we can actually unplug this because this is actually a separate card. So we'll take a look at this in a minute, but let's just get a bit further and finish off taking a look at this. So with this little riser card here, what you have is this metal case. It's got a heatsink in it to cool the NIC. And there's a tiny little fan in there you can just about make out. So we'll take these screws out just for completeness and see what this is. But this is a little riser card that's taking the PCI Express and breaking out to the network card and the M.2 slot. So that's quite interesting. I can't find any sort of information about the M.2 slot, so I don't know what types of protocols or ports it supports. Obviously it supports PCI Express for the NVMe drive, but I don't know if it maybe also supports SATA, or does it not support SATA? Does it have whatever other signaling M.2 ports can have? I'm not sure because it's not quite standardized what they have. It does vary. So yep, that's that board out there. So as you can flip this over, we've got a tiny little fan there and a heatsink here to cool the network cards. That fan will blow air through that heatsink to keep the network card cool. So it is good. I mean, network cards like this do somewhat, they either require active cooling on the card itself, or they're designed to be installed in a high airflow server case where there's a lot of air going through and going across the heatsink. So it makes sense that they put some sort of active cooler on this. And this is the same as those R86 mini PCs. They also had active coolers in them. So, yep, you got that there. These fans are all pretty quiet. We'll talk about the other fans later, but the little built-in fans are pretty quiet. So that's all you've got there. So you've got your M.2 slot here, your connector for that riser cable, that ribbon cable going over to the main board, the fan there, and the bottom, you've got this connection for the network card. So what we'll do now is we'll clean this all up and then take a look at the network card. So now I've cleaned it up, here we have the network card. And as you can see based on the chip there, it's a Mellanox ConnectX-4 L. Just about to see it, yeah, you see it there. And that is a 25 gig NIC. And if you're looking at this and you're seeing that sort of slot there, this is actually a standardized card. And it's known as OCP NIC 2.0. So this is a standard for network cards like this that sort of fit in servers as mezzanine cards. So they'll generally, you have your motherboard and this will slot into the motherboard like that, upside down usually, and clip in. Lots of servers have similar form factor network cards. Some of them use this standard, some don't. I think this has been superseded now with OCP NIC 3, but this is, yeah, OCP NIC 2. So that means on this machine, you could actually replace the network card with another one. because all you need to do is get whatever network card you want, take the included card out, put your OCP NIC network card into this, and it should work. So yeah, it's a standardized card. And the cool thing with these OCP NIC network cards is that they're very inexpensive to buy second-hand. Because unlike cards that fit into a PCI Express slot that everyone can just buy and use on whatever machine they want, these cards are a bit more specialised, so they're a lot cheaper because the only market for them are people that have machines that take them, which is a lot smaller than the market of people that want a standard PCIe NIC. So with these cards, you can even nowadays get like riser card adapter assemblies that would go into a PCIe slot, and you can fit your OCP NIC onto that and put it into a normal machine. But yeah, that's what they're using here. But speaking of these being very inexpensive second-hand, I do somewhat wonder if this is actually a refurbished part and isn't a brand new network card. Now, the reason I say that is, first of all, Mellanox NICs are not cheap. This is a very expensive high-end network card. So fitting something that high-end into a low-cost device like this doesn't really make sense. The ConnectX-4 is also a good few years old now. It has been superseded with more recent models. It's not to say the ConnectX-4 isn't bad at all. These are still great NICs to buy second-hand and put into machines. But it's not the newest card. And if you look on the back here at this little sticker, which is covered in alcohol from cleaning it, whoops, you can see there it's got a manufacturing date of 2018. So I suspect this is potentially a sort of second-hand or refurbished part. I don't really blame them, that makes complete sense. It's a low-cost device and you can definitely get these very cheap in bulk because they're such common devices. But yeah, that's your network card there. But it is really cool to see such a high-end NIC in such a low-cost device, and it's good as it's a replaceable module that you can easily swap out. You're not getting a device where you've got one big motherboard and then the Mellanox chip is just somehow soldered directly to that board or anything. This is a completely replaceable part, so you could replace it if it failed, you could upgrade it, you can move to a different model. If you, say, got this and for some reason your operating system wasn't happy with the Mellanox network card, you could swap it out for an Intel one if you wanted. It's quite versatile having that replaceable module. So yeah, that's your network card there. So now for the final couple of bits we'll take a look at this little board here and this board that's doing the HDMI. They won't be the most exciting, but it'll be interesting to see what's on them. So I've got that board there, and then this one here we'll carefully unplug and get these boards out. Okay, so I've got these two boards here. The boring one first, the HDMI one, it's literally just a basic HDMI to VGA converter, so it's an ASL CS5210. That's a chip on it there, tiny little chip. It's the exact same chip you'll get in all those very basic little sort of passively powered, or those little those converters that are just powered by the HDMI port. It's literally just one of those, but on a PCB instead of in an enclosure. And then I've got this board here that's pretty basic, but there's a couple of little interesting things. So obviously you've got the power inlet here, so this is a 8-pin EPS connector, even though we're only using the 4-pin, so it's just 12 volt in. You've got the mini USB port here, which is the console port, so that essentially seems to connect through onto this RJ45 here. You've then got some connections here, so this larger one is for the on-off switch on the back, and these two smaller ones are for the fans. So this is something to bear in mind with this, is that if you wanted to replace the fans, they're not using a standard fan header, they're using a much smaller connector. So if you did want to replace the fans in this, you're going to need to either crimp those connectors on yourself or cut the connectors off the existing fans and splice them onto your new fans. So it's just something to bear in mind there. We'll talk about the fans in a bit. They aren't the not quietest things in the world, but equally they aren't the loudest things either. And to be honest, the fan in the power supply is probably louder than the case fans, so you're unlikely to really want to replace them. But yeah, if you did, just bear in mind that they're kind of using a non-standard connector there. Next up, you've got this little bank of connectors down here that you can see. And these are kind of interesting. I may be getting this wrong, but you've got these connectors here, two big ones and one smaller one on top. Now, from memory, these bottom two, one of them went to the main board and one went off the network card board, and then the top one only went to the main board. So what I suspect they're doing here is the bottom two are carrying power out of this to the boards, and then the top one is carrying things like the on-off switch signaling, I suspect, and I suppose probably also the power and disk activity LEDs as well. In terms of chips on this, there's this little Nuvoton chip here, which is a Nuvoton N76E003. It's a basic little microcontroller. I suspect what they'll be using this for is things like that on-off switch, because obviously they're probably going to send like a momentary signal to the main board or something. This is probably handling how that works. I don't really know. And there's this connector above that, which is wired directly into the microcontroller. So I suspect this is for programming that chip. The final chip up here is one that has really confused me, and it's a GL3523 USB hub. So I mean, a device with USB ports, a USB hub wouldn't be that confusing, apart from the fact it's got 2 ports on the back and 2 ports there. So I don't know why they're using a USB hub, because if I was designing this, I would have just had this port would connect to this port would connect to this, and it would just pass through. So I don't know why they have a USB hub when they've got 2 ports from the main device and 2 ports externally. That's really weird. So I don't really know. I don't know if anything else on this board's USB capable, and that's why it's there. It's really strange. So what I'll do is, once I've got this back together, I'll fire it up and take a look and see if I can see anything from the software that would indicate the architecture of this. And if I figure that out, I'll jump in now. And if you don't see a clip next, I probably wasn't able to figure it out. So yeah, that's what I've got there. Okay, I'm back actually now testing this out, and I am just as confused as I was before. So what seems to happen is this bottom port, the port that you can't see, the one closer to the front of the machine, that one seems to carry all the data. So if you unplug that, both devices that you've got plugged in at the front disconnect. The other port doesn't seem to do anything. If you're looking at LS-USB, which is what I'm doing on Linux here, if you unplug the top port, nothing changes in the LS-USB output. The only thing I've noticed is that if you've got a device in here that's like got an LED or something on it, if the top port's plugged in and the bottom one isn't, the device loses its connection but still gets power. If you unplug both of these, the device loses power, and if you plug only the bottom one in, it gets data and power. So maybe it's just a weird attempt to get additional current availability, to have 2 cables coming down here to carry enough current. Maybe. It's really weird, because then why wouldn't you just connect each of these through to the front directly? Maybe it's like regenerate the signal or something. It's very weird. Don't know why they've done that. The USB ports work, but yeah, they don't know why they've got those 2 cables. The only other thing I found as well is I tried a 10 gigabit USB device. It doesn't seem to link at 10 gig. So you can see here they're labeled super speed 10. It only linked at 5 gigabits, so standard USB 3 speeds. Now, this may have been a weird compatibility issue, I don't know. I was testing with a Samsung T7 SSD, essentially the one I'm actually recording this video to now, and it would only link at 5 gigabit, even though it's a 10 gigabit device. I also plugged that device with the exact same USB-C to A cable into another machine, and it links perfectly fine at 10 gig. So maybe they are only 5 gig, I think they probably are, maybe they're just mislabeled on the front. But yeah, that's a weird thing with the USB ports. But anyway, let's get back to where we were before. So there we go, that's the inside of this machine. So what I'll now do is I'll go away, put all this back together, and then we'll fire it up and take a look at it working. And it's all now reassembled, so let's fire it up and see if it works, and check I've not broken it. So what we'll do is, first of all, turn the mains on, that's important. So now, if you turn the mains on, you'll hear a slight fan noise because that's the power supply's fan kicking in. And then if we turn the switch on at the back, it'll actually power the thing up. So see the lights come on there. The fans have actually started up properly now, and on the screen here in a second you'll see it boot up. So you see that's it booting up. I've installed OpenWRT on this, I was testing with that. I've tested a couple of different OSs. I've tested pfSense, OpenSense, OpenWRT. So I've tested a bunch of different OSs on it. I'm not sure what I'll ultimately run on this when I deploy it. I want to do a lot more testing with this, try a bunch of different stuff, and then ultimately, eventually, I'll put it in as my own firewall to test it out for an extended period of time. But right now, we're running OpenWRT, and as you can see, it's booting up absolutely fine. Yeah, that's it. And that's it booted up into OpenWRT there. So, yep, it's happily running OpenWRT. One last thing I quickly want to demonstrate while it's working is that weird power switch behavior. So we're booted into OpenWRT, and I'm going to flick that power switch on the back off. Just flick off the rocker switch on the back and watch what happens. So that's turned off, and now you can see the OS is actually doing a clean shutdown. It's not just killed the power to it completely. So yeah, that's that slightly weird behavior there. So now that we're up and running, let's talk performance. As I mentioned earlier, I'm not going to go into too much detail in this video because I don't have any other 25 gig NICs to test with other than the one that's in this. So all the testing I did here was done with another 10 gig NIC, so all my tests maxed out at 10 gigabit, even though this device could probably go a bit faster. So we'll go through some basic performance tests, but I'll probably do a dedicated video on this if there's enough to band. I'll buy a 25 gig NIC and do some proper in-depth performance tests. So this is just more a quick sort of high-level look, really. So with these tests, I installed pfSense and OpenWRT. So I wanted to use one FreeBSD-based version OS and one Linux-based OS. And yes, I know OpenSense exists, I know VIOS exists, I know every other OS exists. Every time I mention some sort of router OS, someone will comment going, why don't you use this one? I know what ones exist, I just chose a couple, but anyway. So yeah, pfSense for FreeBSD and OpenWRT for Linux. Both those worked absolutely fine. I did find one weird bit of behavior in pfSense and also OpenSense because I tried both to see if they both exhibited the same behavior. And that was for one of the tests I wanted to try, was set this up as a layer 2 firewall. So So the way you can do this in pfSense is you basically set up a bridge, so you bridge two interfaces together, you then set firewall rules on that bridge, and it means that the firewall doesn't do any routing. You can just basically pass traffic in and out of this firewall completely transparently, and it'll do firewalling. For some reason, I found weird behavior where if I added these two Mellanox next to a bridge, the machine would almost like get some sort of broadcast storm and lock up. So if I set up a spanning tree on the bridge, one of the ports would always go to discarding. And if I turned off spanning tree, the entire machine would sort of slow down, then lock up. It would draw a lot of power, so it was like the CPU was being maxed out. So it's like some sort of weird internal loop that was happening. And this would even happen if literally there was no network cables connected to this. If I set up the bridge, rebooted, it would do the exact same behavior, even if these network cards weren't connected. It was very strange. Other than that, everything works absolutely fine. And I don't doubt that's an issue with this particular hardware. It's probably some sort of weird compatibility with FreeBSD, I'm not sure, with this NIC. Other than that, it works absolutely fine. So the only thing to bear in mind is it might not work for you if you're wanting to do a layer 2 firewall as like sort of transparent thing with pfSense. Other than that, it's fine. pfSense works completely fine with those NICs. What I might do at some point is when I get that other 25 gig NIC to do more performance testing, I'll buy another ConnectX-4 and I'll try it in a different machine and see if I have the same behavior there to work out if it's an issue with this machine, or more likely it's an issue with the ConnectX-4 with FreeBSD. But other than that, it works completely fine. Just basically maybe think twice you want to use this as like a transparent layer 2 firewall, but other than that, it works fine. All other firewall duties work perfectly. So yeah, let's talk performance. So with each operating system, I tested the raw routing performance, routing between two VLANs or two different subnets on different interfaces without any firewalling enabled. I then enabled the firewall, did the same test, routing between two subnets, and I also did a test with NAT, so one device external to the network, one device internal to the network, and did NAT between them. Both these tests were using iPerf with its standard sort of TCP settings. And then for each test, I ran a single stream test and then a multi-stream test with 4 different threads. That's because sometimes with certain configurations, especially with BSD, some firewall and routing operations are not very multi-threaded, so you need to have multiple streams to really spread it across multiple cores. So I'll put some graphs up on the screen now to sort of visualize all these numbers, because there's a lot of numbers, but it's not that exciting really. Essentially, it can happily do 10 gig in almost all situations. So basically for both OSs, the routing and firewalling were all basically done at 10 gig. So that was completely maxing out the NICs. The other thing to bear in mind is that these performance results are all from iPerf. And the way iPerf works is it only shows the amount of data that was actually passed through, the amount of usable data inside each packet. And it doesn't take into account all the headers and additional data in each packet. So the actual performance figures from iPerf will always be slightly lower than the actual amount of data passing through the interface, which is why these are sort of sitting around like 9.3 gigabit rather than 10 gigabit. It's all that additional header information that iPerf ignores. But yeah, as you can see, it basically gets 10 gigabit on everything. The only time it doesn't is downloading through NAT with a single stream under FreeBSD based OSs such as pfSense. And this is something I found previously when I tested my previous firewall as well. pfSense NAT performance for downloading was always a little bit slower, and I couldn't quite work out why. But a few people commented saying it's because it's very highly single-threaded, and that does seem to be the case, because as you can see, a multi-threaded NAT download through pfSense is completely fine. It gets 10 gig. So I think it is potentially because of maybe NAT under FreeBSD still is fairly single-threaded, I'm not sure. But yeah, other than that, it's completely fine. So Linux, you're going to get 10 gig across the board. FreeBSD, basically 10 gig across the board, but maybe not with NAT. But yeah, this is actually really good performance. The fact that we're able to easily get 10 gigabit on single stream routing is absolutely great. With my previous Atom-based router, single stream you're maxing out about 2.5 gig, and with multiple streams you're maybe getting 6.5 gig. It wouldn't do a full 10 gig, whereas this can easily do a full 10 gig. So yeah, that's the performance. It's really, really good. And it'll be interesting to see what I get when I actually get a 25 gig NIC. Will it actually be able to get 25 gig? I think that's maybe going to be pushing it, but we'll see. Be really interesting to see that, because yeah, right now we're definitely hitting a limit of the NIC and not a limit of this machine here. Next up, let's talk power consumption, because this is one area where this device does have a bit of room for improvement. And by that I mean that the included power supply while it works isn't the most efficient. So what I did for this testing is I had OpenWRT running, basically idle, not really passing any traffic. However, one of the 2.5 gig NICs was linked at 2.5 gig, and the two 25 gig NICs were linked at 10 gig using SFP DAC cables. So it was kind of sitting at idle, but it was connected to the network. and I took these power measurements. So with the original power supply, from the wall, it drew 29.5 watts. That doesn't sound deadly. I mean, I've got a lot more machines that draw more than that. But it is a low power device. I thought that's maybe a little bit high. Bear in mind, you are running a very high-end NIC, so that will draw a fair bit of power. But yeah, from the wall, it was drawing 29.5 watts. But what I then did was I measured the amount of power being drawn from the DC side. So the amount of current coming from the power supply into this board here, completely ignoring the amount of power being drawn from the wall, to measure the actual power being drawn by just the internals. And when it was pulling 29.5 watts from the wall, the internals were only drawing 17.1 watts. So that gives this included built-in power supply an efficiency of 58%, which isn't really that great. And this is the issue with using like a high power, like 250 watt power supply for something like this, is that because you're loading it so little, it's not reaching its peak efficiency because you're putting such little load on this power supply. Additionally, this is not a very efficient power supply. It's basically unbranded. I mean, this is the only branding is the Gowin sticker. There's no other branding on it that I can see. So I think it is a very low-end power supply and it's just not very efficient. So what I then did was picked up a few different power supplies I had sitting around and tested them to see how they performed in comparison to this. So the first power supply I tested was this Meanwell open frame power supply, which this one here. And I connected this into the board on the Gowin server. And from the wall, this only drew 20.7 watts. So that has an efficiency of 82.6% versus 58% for the OEM power supply. Now, of course, this power supply you couldn't really easily mount into this case. It'd be a bit tricky to try and install, and it's not got all the main stuff at the back. It wouldn't really work that well. So I'm not going to be able to put that in. But what I then thought is, what other Flex ATX power supplies can I test with? So I had this spare AcBell 400 watt 80 plus gold power supply. I pulled this out of my Datto server, the server I nicked the motherboard out of to build my home server. I had it sitting around, so I took the power supply out of that and tested this. So this is 400 watt 80 plus gold, and the model number is FSE001, so that's it there. The AcBell FSE001. And with this installed, I was only pulling 23.5 watts from the wall with an efficiency of 72.8%. So significantly more efficient than the original power supply, despite this being a 400 watt power supply. So this is running even lower on its efficiency curve than the included one, but actually pulled much less from the wall and was much more efficient. So yeah, that was an interesting observation. Of course, this is 80 plus gold. This isn't remotely certified for any sort of efficiency rating, so that's probably why. However, annoyingly, this won't actually fit because it turns out Flex ATX has a standard depth that matches this power supply here, but some Flex ATX PSUs can be deeper, and this is one of those because I think it's 400 watt. That's quite high power for a small power supply like this, and it's that little bit too deep, and it means it won't line up with the mounting bracket that this power supply is mounted to, which you can see in there. It's mounted to this plate here, and that won't line up on the other power supply, unfortunately. So yeah, I won't be able to actually use that AcBell power supply. But what I then did was I nicked a power supply out of another server I have. So I don't have it here because it's back in that server because I need that server to run. But essentially it's the same as this, except it's 80 plus bronze, but it's only 250 watt. So it's an AcBell, I think it's an FSC 008 or something. So it's a 250 watt, 80 plus bronze power supply, very similar to this, but it's a little bit shorter, so it would actually fit into this case. And with that power supply, we had a total power draw of 23.2 watts, so an efficiency of 73.7%. Actually more efficient than this one. So that goes to show why using a lower wattage power supply can actually be more efficient. This is 80 plus gold, but actually got worse efficiency than a 80 plus bronze, but lower wattage power supply. So that's quite a stark contrast comparing, say, a 250 watt efficient power supply to this very low end 250 watt power supply. 29.5 watts versus 23.2 watts for the exact same load. So it's a little bit annoying. What I think I'll actually do is I'll possibly buy another one of those AcBell power supplies and put it in here instead, because the power supply costs about £20 second hand on eBay, and I worked out with current UK energy prices, which are pretty high, that power difference would pay for itself in about a year and a half. It's that much of a difference, not to mention, being better for the environment and, producing less heat. So yeah, that's the only real complaint I would have, is that this power supply just really is inefficient. The most efficient way to do this would be like that other machine, to have a open frame power supply wired to an AC inlet on the back, because for those you could get like one that's 150 watts, 100 watts, 75 watts, a much lower wattage, which would run much more efficiently. But with this, because I'm limited to having a Flex ATX power supply, I think I'll pick up another one of those 250 watt ACBell power supplies, swap this one out, and it'll work fine. But yeah, so that's the performance results. Out of the box, it idles around about 29.5 watts, but you can significantly improve that with a more efficient power supply. So finally, let's talk noise levels. So we're sitting here at idle with all the fans running, and we're sitting around about 56 dBA. Obviously, I've pressed hold on this, so it's holding this value because I'm talking right now. But we're sitting around about 56 decibels with all the fans running. And to be honest, this isn't too bad. You wouldn't want it maybe sitting next to you, but as long as it's in a cupboard or something, it's not that bad. It's definitely audible, but it doesn't sound like a server screaming away or anything. But, you know, you do hear it. But one important thing to bear in mind is that obviously those two 40mm fans could be replaced, but even though they make some of the noise also comes from the fan built into the power supply. So even if you were to try and replace those fans with really quiet Noctuas, you're probably not going to get that much of a saving. So what I'll do now is I'll quickly disconnect the internal fans, leave the power supply fan connected, and we'll see what it sounds like. So I've now disconnected both the internal fans, and we're now sitting around about 54 decibels. So you're not really saving that much by upgrading the internal fans to quieter ones, really. It's that power supply fan that's the noisy one. Of course, that does then mean if you were to replace the power supply with a more efficient one as well, you could also try and get one that's got a quiet fan. They're quite widely available to get silent fan Flex ATX power supplies, and you kind of kill two birds with one stone, get a quieter fan and a more efficient power supply. But yeah, if you're buying one of these, I wouldn't bother about sort of straight away wasting your money and buying new quieter fans, because that power supply fan's still going to be quite loud. I think it's temperature controlled, because when you first turn it on it's quiet and then it slowly starts ramping up and getting louder, so it may get even louder if it was put in a hot cabinet, I'm not sure. But yeah, that's the sort of sound level test there. Then what I'll do now is I'll quickly unlock that and I'll turn it off just to get a background reading. So yeah, background reading there around about, what, 38.5, something like that. It's not a silent room. I've got a server rack in the corner. My video lights have fans in them, so that's not really helping. But yeah, that's getting the noise levels. So there you have it. That's a look at this brand new 1U server from Gowin. And this thing is absolutely great. Sure, there's a couple of little improvements I would make, and hopefully I'll take that feedback on board, but it works absolutely brilliantly. The performance is absolutely fantastic. The fact it can easily handle 10 gig network traffic is great, and it'll be really interesting to see what I can do when I've got another 25 gig card to push this to its full potential. They're very generous with the specs. 32 gigs of DDR5 RAM is absolutely great. Having three 2.5 gig NICs is also absolutely awesome, especially with multi-gig WAN connections coming in. And then being able to get something of this form factor for this price with a pair of 25 gig network interfaces is absolutely brilliant. So yeah, very happy with this thing, and I'm really interested to see what I can do with it going forward. So there you go, thank you very much for watching. Now, as I mentioned earlier in this video, this isn't currently available for sale. They're still about to launch it and it'll go on sale very soon, but as soon as that happens, I'll update the description and put a pinned comment with links on where you can buy this. But all I have to say now is thank you very much for watching, and stand by for future videos on this device.